in 7, again, is a very, very similar idea. So this paper is actually quite easy because the first set of questions are always very similar. So it's all the body of mass 0.5 kilograms. So again, write down the key bits of information. So mass is equal to 0.50 kilograms. Okay, and it's fixed to one end of a string. We're taking vertical circle. Doesn't matter what kind of circle it is, horizontal, vertical, it's still a circle. We're still going to be looking at centripetal and centrifugal forces. Okay, so the radius is also radius is 1.5 meters. So we'll keep it information. An angular speed. Okay, so the angular speed is 2 pi over t, or the velocity divided by the radius. Okay, and that is 5 radians per second, or 5 rd s to the minus 1, or r s to the minus 1, however you want to write it, doesn't really matter. Okay, what is the maximum tension in the string? In other words, when is the centripetal force at its greatest? Okay, because obviously the force in will be equal to the force out, and the force in is the tension. Okay, so let's just draw an example of this, just to visualise it. So we've got the centre of the string, we've got this object here, it's attached on this rope, okay? Where is the tension going? Okay, well, we've got a force here, we've got a force going, say it's going round this way, we've obviously got the velocity this way, and we've got 2 forces here. Well, we've got the centripetal force here, and if there is no other forces, okay, we assume that the centripetal force is equal to the tension because the resultant, the other forces of friction are acting outwards, okay, so frictional forces, or centrifugal, okay, so we've got frictional, centrifugal, whichever way you want to talk about it. So therefore the only other force, it must be the tension, and for this to balance the tension must be acting inwards, but that doesn't really matter, okay. Either way, you'll end up working it out the same way if you didn't visualise it like that. Okay, so key bits of information, mass, radius, and angular speed. Okay, now you could work out the time period, okay, if you wanted to do the long way around, okay, so we'll do that. So the angular speed of 5 r to the s minus 1, okay, and that is equal to, as I said, to the velocity divided by the radius, okay. So if we times that by the radius of 1.5 meters, okay, we will get the speed, okay, the velocity. And the reason why I'm doing that is because we want to work out F equals mv squared, okay, over r for the tension, okay, and obviously therefore we're going to need the velocity. So just remember that again, so the angular speed is equal to the velocity times the radius, or the velocity divided by the radius, okay, so if we want to get the velocity, we need to times the angular speed by the radius, which is what we've done here, okay, so therefore that is 7.5 meters per second, okay, so we've got the mass, we've got the radius, and quite clearly see them two combined with the angular speed give us the F, okay, it's centrifugal force, in other words a tension, because F is equal to the force is equal to the tension. And it doesn't matter if you think the tension's going this way or that way, the force should be equal to the tension, otherwise there is absolutely no way this can abide by centripetal force, the circular motion, okay? So F is equal to mv, so the mass is 0.5 times 7.5 squared over the radius, which is 1.5 meters, okay? So it's just a case of putting them numbers into your calculator. Oh, for God's sake. Yeah, you do need to, there's something else I missed out. Again, I'm sorry about this. I've assumed it's a, not included, something. Okay, it's a vertical circle, not a horizontal circle. So something else I missed out. So yes, this is the force. Okay, but this is not equal to the tension directly, okay, so I do apologise about this. So it's a vertical circle, so we've got to, they wouldn't have said it's vertical circle if they didn't want us to modify it in some way, okay, so let's visualise a vertical circle. So it's at the bottom point, let's assume that, we've got the weight, mg, so therefore the thing opposing it, okay, so I did include it with frictional forces here, sort of, so therefore the action towards the centre must be the tension. And the difference between these two must therefore be the centripetal force F. Okay, in other words, F is equal to T take mg. Now, the reason it's T take mg and not mg take T is because in this instance, okay, the if mg was greater than T, then it would be falling, okay, and it's not, and it's going around in a circle, so therefore T must be greater than mg, so the difference between the two is a centripetal force. And this is a very good example of what we mean by the centripetal force, because people think, oh, is it a force on its own? It's not. It's F is the resultant between two different forces. In other words, it is the difference between two forces, okay? It's not a single force on its own acting by itself. Okay, so therefore T take mg is equal to the centripetal force. Okay, so this F is this F here, so therefore the F is equal to T take mg, as we said, so therefore you work out what mg is and rearrange to get T. Okay, so therefore T is equal to F plus mg, okay, we've shown what F is here, whatever that comes to, okay, and you add to that the mass, which is 0.5 times 9.8, or I'm just going to write 0.5 g, which is 4.81, okay, so therefore the tension is 24 newtons, okay, which is answer D. So I do apologise about that. So 7 is D, and hopefully you see why that is. And I personally think that's a very good example on showing the difference between the forces. Okay. Now the next set of questions are on simple harmonic motion, so I'm just going to pause the video and then I'll start it again for the next set of questions.